So we are on to theorem of total probability, and that's what we are going to discuss in exercise 13.3. And coming on to theorem of total probability, let's say to understand this, let's say we have this sample space where we have n number of events, and obviously there is uh, the number of events, and let's say there is an event A in that. So other events, let me just denote it by E1, E2, say E3, say E4, and it goes on like this till event N. So this all these events makes up the sample space of, let's say, a particular experiment. And so E1, E2, E3 till En. This makes up our sample space for a particular experiment where A is also an event, and also the probability of all these events up to the nth event, that is probability of E1 En, is non-zero. So theorem of total probabilities says that if we have to find the probability of this event A, so because it's mentioned that it's the total, so obviously we have to deal with the sum, and it should be now probability of event E1 into probability of event A when E1 has happened, plus probability of event E2 into probability of event A when E2 has happened, plus probability of event E3 into probability of event A when E3 has happened, and it goes on till the nth event, that is probability of nth event into the probability of A event when nth event has happened. So if we have a number of events that makes up the sample space of a particular experiment, and uh, among them we have to find a probability of, let's say, event A. So this is how we are going to find out the probability. So this is what the theorem of total probability says. And this can also be written as probability of A, that should be summation of I to n, let's say, and see, we will just change EI into probability of A by EI, where EI goes from I to n. So this is the theorem of total probability. And moving on to the next topic, that is our Bayes theorem. So Bayes theorem is actually a combination of conditional probability and the reverse probability. And to understand this concept, let's try to frame it with a particular example. Say there is a factory that manufactures a pen using three machines. Using three machines. So let's say our machine is E1, E2, and E3. Let me say it's machine 1, machine 2, or machine 3, and the capacity of manufacturing a pen from these machines is 50%, let's say 25%, and 75%. And now, because a pen is being manufactured, a factory that manufactures a pen, so let's say a defective pen is also one of those pens, and let D be an event that a pen is defective. The D be an event that a pen is defective. And the probability of getting the defective pen from machine E1. Probability of getting the defective pen manufactured by a machine E1 is, let's say, 1%. And probability of getting the defective pen by a machine 2 is, let's say, 2%. Probability of getting the defective pen by machine 3 is 3%. And because I was talking about the reverse probability, so reverse probability would be an condition like, let's say, uh, defective pen is manufactured, but it has to be come from machine 3. So this is the reverse probability. And how we are going to get this? So this should be probability of machine M3 getting manufacturing a pen by machine M3 into getting the defective pen from machine M3 divided by the total probability. So total probability will be probability of manufacturing a pen by machine M1 into defect probability of getting the defective pen by machine M1 plus probability of manufacturing a pen by machine M2 into probability of getting the defective pen from machine M2 plus probability of manufacturing the pen from by machine M3 into probability of getting the defective pen by machine M3. So this is our base theorem that helps us to find the reverse probability. And let's try to solve this example of exercise 13.3, wherein an urn contains 5 red balls. So red balls are 5, 5 are black balls, and so total balls are 10. And the question says that we have to draw a ball. So if a ball is drawn, then it could be either red or it could be either black. So let even be even. That first ball is red and E2 be even. That first ball is black. So probability of getting a red ball is, and probability of getting a red ball is 5 by 10. Probability of getting a black ball is also 5 by 10. Now it's said that when you draw a ball and you know down the color, we have to add 2 additional balls of the same color. And then we have to draw a second ball. So what would be the chances of getting the second ball as red? So let's say let R be even of drawing out a red ball, and say first ball is red. Let first ball drawn is red. So we have to add 2 red balls. Now first ball drawn is red, that means even has occurred. So now the red balls are 5 plus 2 is equal to 7. Black balls will remain as 5. So total balls are 12. So even has occurred, and we have to now draw the second ball. So probability of getting the red ball when even has occurred is 7 by 12, and probability of getting the red ball when even E2 has occurred. So even E2 means that the first ball is black. We don't have to add the red ball, but we have to add 2 black balls. So the red balls will be 5, and the total balls will be 12 because the 2 black balls we have to add. So these are the probability of getting the red balls in both the cases, but we have to find the combined probability of the red ball. So that would be probability of the red ball into probability of getting the red ball when event first has occurred. and probability of getting the black ball into probability of getting the red ball when black ball is drawn. So this is 5 by 10 into 7 by 12 plus 5 by 10 into 5 by 12. So this gives 35 by 120 plus 25 by 120, which gives 70, sorry, which gives 60. This gives us 60 by 120, and that should be half. So this is our answer for question number 1. And moving on to question number 2. So that's how the question number first is solved. Let's now move on to question number 2. Thank you for watching.